What is the difference between elastic and plastic strain? Imagine bending a paperclip. If you gently bend it and it springs back to its original shape, that's elastic strain. If you bend it too far and it stays bent, that's plastic strain. Elastic strain is the temporary change in shape or size a material experiences when stress is applied. Once the load is removed, the material returns to its original form. Think of it like stretching a rubber band. It stretches, but snaps back when you let go. This happens because atoms in the material shift slightly but return to their original positions after unloading. The relationship between stress and elastic strain is straightforward. It follows a linear pattern, meaning if you double the stress, the strain doubles too. This is called Hooke's law. It applies only when the stress stays within the elastic limit of the material. If you go beyond this point, the material no longer behaves this way. Now, plastic strain is different. It happens when the stress exceeds the elastic limit, also called the yield point. When this occurs, the atomic structure of the material changes permanently. Dislocations or shifts in atomic positions cause the material to keep a new shape even after the load is removed. Imagine bending a metal wire past its elastic limit. It stays bent. Plastic deformation is nonlinear, meaning the relationship between stress and strain becomes more complicated. As you continue to apply stress, the material might harden or become more resistant to further deformation. This process is called strain hardening. It's why some metals can be shaped or stretched more without breaking once they have been plastically deformed. Understanding the difference between elastic and plastic strain is key to preventing product failure. If a material only undergoes elastic strain, it can recover fully without damage. But if plastic strain occurs, the material has been permanently deformed, which can weaken it and lead to cracks or breaks over time. Engineers use this knowledge to design safer, more durable products. They want to keep stresses within the elastic range during normal use. If a load causes plastic strain, the part might be permanently deformed or fail. That's why knowing the limits of elastic and plastic behavior helps prevent mechanical breakdowns. To sum up, elastic strain is reversible and happens below the yield point. Plastic strain is permanent and occurs after the elastic limit is crossed. Elastic deformation involves small atomic shifts, while plastic deformation involves lasting atomic rearrangements. Elastic strain energy can be recovered, but plastic strain energy contributes to damage and weakening. Recognizing these differences helps us understand how materials behave under stress and why they sometimes fail.